Okay, talking about exponents. First off, if I have something like this, 5 to the second power, what is the 5 called? The 5 is called the base. What is the 2 called? Exponent. The exponent. What does 5 to the second power mean? It means 5 times 5. One of the biggest mistakes is people say 10. Yeah, saying that it's 5 times 2. Well, that's not what it means. It means 5 times 5, which is 25. So as we go through, I don't want to go there. As we go through and do things like, say we have x to the 4th power. How could I write that out in expanded form? X times x times x times x. That means that there's 4 of them. Okay? So if I went backwards, if there's 4, there's no exponents written up here. What exponent is on it? A 1. So one of our rules for exponents is that you take these when they're all in expanded form, and when you're multiplying the bases, you add the exponents. And that's how, if I started with this one, I would go backwards and go to x to the 4th. What if I had x to the 6th times x to the 4th? What would you do here? You are multiplying the bases, so the bases stay the same, and you add the exponents, which would give us x to the 10th. Okay? Shouldn't be that big a deal. So if I had another one, oh, let's see if I can write that a little better. There we go. All right. X to the 7th times x to the 4th times x to the 2nd. Answer that question real quick. So right here, you're going to multiply. You're multiplying the bases, so you add the exponents. So right here, I've got x. 7 plus 4 is 11, 12, 13. Okay, what about this one? Do this problem real quick. On this one, when you're multiplying, you're going to multiply the coefficients just like you normally would. And it would be 2 times 3, which is 6. And what did I just say you did with the exponents? Add them. So it should be x to the 12th. That's our answer. Let's try another one. Okay, so let's try this one right here. Okay, on this problem, again, we're going to go and we're going to multiply the coefficients. Well, 4 times 3 is 12, right? 12 times 2, so we're going to have 24. And then my bases are x. Add the exponents. So, yeah, so 6 and 7 is 13, plus 3 is 16. Okay? Try one more, and then we'll go on to the dividing. Yes, it's a 7. Okay, let's just go with that one. Right there. multiply the coefficients, negative 12. Now you're saying x to the 8th. How are you getting 8? There is a 1 right here. Yes, and so 7 plus 1 is 8. Very good. Now, the next ones when we're talking about dividing. So when I have x to the 7th power over x to the 4th, if I wrote this out in expanded form, 1, 2, 3, 4, 5, 6, 7, all over x to the 4th. Okay? From here, these cancel out. These cancel out. They make 0. They go away. What am I left with? I am left with 3x's up top, which would be x to the 3rd. So when we are dividing the bases, you subtract the exponents. And it is 7 minus 4. You always take the top number minus the bottom. Okay, so let's go here. What if I had x to the 10th over x to the 2nd? Answer that one. If you subtract the exponents, right here, 10 minus 2 is 8. It's x to the 8th. What if I had 16 x to the 7th over 2 x to the 2nd? What would that one be? Right here, you would divide 16 divided by 2 is 8. And then you subtract the exponents. 7 minus 2 is 5. Okay? Now let me remind you about something. What is anything to the 0 power? So if I had x to the 0 power, it is 1. Because that's like having x to the 2nd over x to the 2nd. What is 2 minus 2? It's 0, so it's x to the 0 power, which is 1. Well, that makes sense because that's the same as x times x over x times x. Well, they would cancel each other out. And they don't just disappear. There's got to be a number there. That's why it's 1. All right, so let's try. What if I did this? Try this problem. Let's combine the two rules. Okay, on this one, what you're going to want to do is do the top part of the equation first. Okay, so let's do the top first. And I get 2 times 8 is 16. And when you're multiplying, you add the exponents. So it should be x to the 8th over. Now, we'll just bring this over and leave it alone. 4x squared. Now, let's do our dividing rules. 16 divided by 4, it is 4. And you subtract the exponents. So it's x to the 6 because 8 minus 2 is 6. Okay, let's try another one of those. Golly gee willikers, let's see. All right, there's the next one. Do this problem right here. Okay, on this one again, you're going to go through and do the top right here first. So as we go through the top here, I've got 6 times 8, which is 48. Add the exponents, x to the 14th. Bring the bottom part over to x. Well, 6 times 8 is 48. Add the exponents, which is 4 plus 10 is 14. Bring this bottom part over here. Now, divide right here. It should be 24 x to the 13th because there is a 1 here, and 14 minus 1 is 13. Let's see. There we go. There's the next problem. Try this one. Okay, on this problem right here, we are going to do the top again, right? Oh, I didn't mean to mark like that. I was trying to highlight. Here, there we go. Okay, so I have negative 8 times 2, which is negative 16, x to the 6, because you add the exponents, and even though it looks like I crossed it out, there's a 1 right there, all over 2x to the 3rd. So now I have, take negative 16 divided by 2, negative 8, subtract the exponents. 6 minus 3, x to the 3rd. Now, one thing I haven't added in there now, we had the power to a power rule. So we had, like, if I had a to the 2nd power to the 3rd power. Well, you can do this a couple of ways. What this means is I've got a squared 3 times. So I've got a squared times a squared times a squared. That's what that means. Now, if I take the rules of exponents, I would add up the numbers, and I would get a to the 6th. Well, when it's a power to a power, you are actually multiplying these. So, because see how there's only one base? If there's only one base and there's 2 exponents, you multiply them. Okay? So why don't you try, what about this one? Whoops. I keep writing those 7s kind of crazy. Makes me want to Ralph. Inside joke. All right, to those of you at home watching the video. All right. What do you do with the exponents here? You multiply it, so it should be a to the 28th. What if I had this? Right here. Take a minute and try and solve that. Okay, on this one, if you wanted to look at it, you could see it as 2x squared times 2x squared. Your answer should be 4x to the 4th. Where people get this messed up is they forget about 2 to the 2nd power. So this is 2 to the 2nd power, and then x squared to the 2nd power. That's where I'm getting 4x to the 4th. Okay? Try one more. Try this one. Okay, on this problem right here, this is 3 to the 4th power. Right? 3 to the 4th power means 3 times 3 times 3 times 3. Well, without a calculator, this is 9. It's 81? Okay. So if you take 3 to the 4th power, it's 81. Please make sure that you do not make the mistake by just taking 3 times 4. And then x, now you multiply only the exponents. So it's x to the 8th power. Okay, from here, now we're going to go. Oh, I don't want to do that yet. Let me get the right page. There we go. So if we have negative 2 x to the third power all to the second power. Okay, take a minute and try and do this problem. I want you to remember that this exponent up here means that we do it 2 times. So we have negative 2x to the third times negative 2x to the third. Sometimes, especially when this exponent out here is smaller, it's easier to write it out to figure out what you're supposed to do. We're going to take negative 2 times negative 2, which is 4, and x to the, add these exponents, x to the 6th power. If you did it without writing it out, you would see here that you have negative 2 squared, which is negative 2 times negative 2, which is 4, and then you multiply the exponents, which is x to the 6th. What if we went through and had this problem? Okay, let's take a minute and try and do this problem. If you're at home, pause the video and come back and see how you do. First off, what you're going to do is this top portion right here. Do what's in the top. Now, with that being said, I'm going to do this part. Oh, let's see if I can have another. I'm going to do this part here first. A power to a power. So I have 2x squared to the 4th power. 2 times 4 is 8. So I have x to the 8th. Then rewrite this second part. 2x to the 5th. All over x to the 7th. Well, now, let's go through and do the top part right here. With this part, I have the coefficient 2 stays the same. When you are multiplying, you add the exponents. 8 plus 5, so it's x to the 13th over x to the 7th. But we're not done. Now, you need to use the subtraction rule right here. You get 2x to the 13 minus 7 is 6. This is your answer right here. Now, what about when we have negative exponents? Say I have x to the negative 2. How can I rewrite that so I have a positive exponent? This is the same as saying that it is over 1, right? Because it's up in the numerator. To make this a positive exponent, you flip it over. So I have 1 over, and then I just put this at the bottom in the denominator. By doing that, it makes my exponent positive. So if I had 1 over x to the negative 3, how can I rewrite that to have a positive exponent? If I flip it over, it becomes x to the 3rd power over 1. I know that anything over 1, I don't have to write the over 1, so it's x to the 3rd. Okay, so let's take a minute here. Let me see if I find which one. Okay, so what about right? These two right here with positive exponents. You should know right here in this one labeled number 4 that this is over 1. If I flip it over, it's 1 over 3 to the 2nd power. Well, that ends up being 1/9. So if you don't believe me about the rules of exponents, put in your calculator 3 caret negative 2. It'll give you the same as 1/9. So number 5, to make it a positive exponent, I flip it over, x to the 3rd over 1, and so it's just x to the 3rd. Let's see on these next ones here. There we go. Write those two with positive exponents, please. I know that this is over 1. So if I flip this over, I get 1 over x to the 6th. Number 7 right here. Again, it's over 1. Flip it over. 1 over y to the 3rd. All you're doing is flipping it over to make it a positive exponent. Yes. Let's take a minute and let's try and do this one right here where we're multiplying. So pause the video and try and answer this. Okay, for this problem, we're going to go through and we're going to take care of the coefficients. 10 times negative 3 is negative 30. Add the exponents, so I have x and x, so 5 plus 7, x to the 12th, then the y's. Now I have y to the 7th, and this just says a y. What exponent is with that y? It is a 1. So I should have y to the 8th. Do I have, there's a z left here. Is there any other z's? No, so you just put z to the 2nd power. Okay, let's try the next one. There it is. Okay, for this one, let's go and look at our coefficients. I have 2 times 6, which is 12. Look at my x's. You're adding the exponents. So if I add them together, what's 3 plus negative 3? It is 0. You could write this. I'm going to leave this alone for just a second. And then the b's. This is b to the 1st power. And then b to the negative 6. If you add them, you get b to the negative 5th. Now, anything, so x to the 0 power is 1. So this really, we don't even write this. They just cancel each other out. So one of the ways the answer could be written is 12b to the negative 5. Or is there another way we can write it? How can we write it to have positive exponents? It's going to be 12 over b to the 5th. Okay, no, but, well, somebody said 1 over b to the 5th. It does flip over to 1 over b to the 5th. But remember that 12 is over 1. And if we did 1 over b to the 5th, and you multiply, it's 12b to the 5th. Okay? There's the next two. Why don't we take a minute and try and answer these two? Remember that when we are dividing, what do we do with the exponents? We subtract them. Okay, so on number 10 right here, if I go and I'm going to take my coefficients, I'm going to divide. 16 divided by 4 is 4. And my x's, 4 minus 3 is 1, so it's x to the 1st power, which normally we just write it as 4x. The next one, right here, I take my b's. 6 minus 3 is 3. B to the 3rd power. The c's. 5 minus 2 is 3. All you're doing is subtracting. Oh, let's see. Yep, let's go ahead and pause the video. Let's do these 4 problems, and we'll come back and see how you did. Okay, looking at the first one, a lot of times, if there's just a 2 out there, sometimes it's easier to write 3y to the 4th times 3y to the 4th. So just to try and help you remember. 3 times 3 is 9. One of the biggest mistakes is people go 3 times 2 and get 6. It is 3 to the second power, which is 9. And then 4 plus 4 is y to the 8th power. So look at your paper and see, is that what you did? Did you take 3 times 2 and get 6? Okay. Remember that that means 3 to the second power, okay, which is 9. The next one, I know it says to the 4th power, but one of the things to help you remember is you could write it out 4 times. Whoops. Okay, and you could then, if you write it out 4 times and then do it that way. Well, I know that I've got 4 to the 4th power. Well, okay, I don't have my calculator in front of me. What is that? 4 to the 4th power. Guess I'll get it. You guys are not telling me. It's not 16. It's 4 caret 4, which is 256. Okay? You put in the calculator the 4, the caret sign, and the 4. All right, so now we multiply the exponents, so it should be x to the 12th, y to the 8th. That's what you should have gotten. The next one down here, first thing you want to do is the exponent, like the power right here. So I'm going to rewrite the first part. And let's do this right here. This is negative 2xy times negative 2xy. That's going to give you a positive 4 x to the second power, y to the second power. Now from here, multiply your coefficients, negative 16, and add your exponents. X to the 7th, y to the, what is that, 3 plus 2, y to the 5th, z to the 7th. The very last one in this set, you'll do this part. You're going to leave this 2 till the very end. So I'm going to have this 2 outside the parentheses. Again, this is 3 squared. 3 squared, I should have 9. X to the second power raised to the second power. Okay, multiply those exponents. 2 times 2 is 4. Y to the 8th. Because 4 times 2, when it's a power to a power, we multiply. Now from this part, multiply these two numbers. So I get 18, x to the 4th, y to the 8th. Let's try one that I just make up. Okay, take a minute and do this one. This will be the last one we do on this exponents video. Okay, so on this one, I'm going to take, when I'm dividing, I subtract the exponents. 7 minus 3 is a to the 4th. Now, what exponent is with this b? There is a 1. So it's 1 minus 7 is b to the negative 6. What happens to the c's? They grow away. They go away. So I have this. This is one form you can have the answer. How can I write this so that I can have positive exponents? A to the 4th is already positive, right? You leave that alone. So move this down in the denominator and you get b to the 6th. Okay, so let me just do a recap real quick. When you are multiplying, when you're multiplying the bases, you add the exponents, right? So I have x, and what I'm doing is taking 2 plus 7, which gives me x to the ninth. When I am dividing, you subtract. So when you are dividing bases, you subtract the exponents. So in this problem, I would have x 2 minus 7, which gives me x to the negative 5. Now, let's add the other part to that. If I wanted to make that, this right here, I wanted to make it a positive exponent, how could I rewrite that? 1 over x to the 5th. Okay, so to make it positive, negative, you just flip it from the numerator to the denominator. The only two that I have left, anything to the 0 power is always 1. The other one that we had was a power to a power. So x to the 3rd power to the 2nd power. When it is a power to a power, you multiply the exponents. Kind of like Bebe's kids. They don't die, they multiply. So you would come up with x to the 3 times 2, which would give you x to the 6th.